All right. Today let us discuss this paper, JEE 2017 paper which was conducted today. Except for the few questions, I think it's a very easy paper. Okay, let us start. Discuss one by one all the questions. The set that I have with me is code A. All right. Question 1. A man grows into a giant such that the linear dimension increased by a factor of 9. Assuming that his density remains constant, the stress in the leg will change by a factor of what? Very simple question. We know that what stress is basically? Stress is force upon area. And when you talk about force, you can straight away think about the weight of the person as mass. Any mass is density multiplied by volume, and volume is basically having a cube of linear dimension, that is the LBH, R is R cube. In any form you take the structure, volume term will have a length in 3 dimension and area will have a dimension 2. Okay, so you will be left with what? If you take the mass, that is density, to be constant and some L cube term here and area to be L square term here, so you will be left with only one dimension of length L, and as the linear dimension have changed by a factor of 9, then the stress also will change by a factor of 9. So 9, correct answer will be 1 for problem number 1. Okay. Second problem, it doesn't need any explanation because a ball is thrown vertically upwards. We have done many times. You see, when you're throwing something upward, take the upward direction to be positive. So you will say we started off with some velocity u or v or whatever we name it. Now what will happen? In which direction is the motion? Upward direction. Which direction is the gravity acting? Downward direction. What will happen? The body will come to rest once, and then what will happen? The speed will increase. It will increase in the downward direction. So first graph is overruled. You know why? The second one, the time is decreasing, overruled. The third one is correct answer. Okay, and you know, we have discussed this many times. See, if you throw something and it comes back to your hand, the dimension, the area under the curve should be 0. So though, you see, this can be the only possible graph in this, which you can see is answer number 3. All right, question number 3. Now in question number 3, they have given you the mass. M is equal to 10 to the power minus 2 kg. They have given you the force. Force is minus kv square. This is velocity dependent force. So you can write this as m dv over dt is equal to minus k v square. Let us arrange it. M dv over v square is equal to minus k dt. Next, they have told you something. What they have told you, that initial velocity v naught is equal to 10 meter per second, that is at t equal to 0. At t equal to 10 second, the velocity becomes v naught or v final will be equal to what? You see, the energy has become 1/8 of 1 by 2 mv naught square. Here the energy was 1 by 2 mv naught square. You know, if the energy reduces by a factor of 4, mass remaining same, the velocity term will reduce by a factor of 2. So the velocity from 5 has reduced by a factor of 2 to 5 meter per second. Let us put the values. Let us put integration. When the time was 0, velocity was 10. When the time is 10, velocity is 5. M, we know 10 to the power minus 2. This term dv by v square is minus 1 by v. That minus and this minus you can lose. So I will be left with 1 by 5 minus 1 by 10. Here I will be getting a k term and dt will give you t, that is 10. Take the LCM here, 10. So this will be 2 minus 1, that is 1 by 10. This 10 can come down 10 and then to the power minus 2 k. So you get k as equal to 10 to the power of minus 4. Alright, and appropriate units can be chosen. Answer for this will be 3. All right. So for problem number 3, the answer is problem number 4. Now the fourth question has given you a time dependent force. So F is given to you as 6T. All right. You can write this as M dV over dt is equal to 6T. M is 1, dV will be equal to 6T dt. 0 to 1 you go, let us say the velocity changes, it starts from rest and becomes V. So V is equal to 6T square by 2. T is 1 here, so this becomes 3 meter per second. Now they want the work done by this force in 1 second. So you know that work done by all the forces, external forces, equal to 1 by 2 of mv square, that is 9. So the answer is 4.5 meter, 4.5 joule. So correct answer for this is 1. Work energy theorem. Question number 5 now. Question number 5 tells the moment of inertia of a uniform cylinder of length L and radius r about the perpendicular bisector is I. What is the ratio L by R such that the moment of inertia is minimum? You know the formula. About the symmetric axis, it is mr square by 2. About the perpendicular axis, transverse axis, the moment of inertia is given as m L square by 12 plus m r square by 4. We know this. We also know that volume of any cylinder is pi r square L. This is some constant, just name this as some constant C, doesn't matter. So from here I can replace r square if I so desire. R square can be replaced as C pi L. So I get I is equal to m L square by 12 plus m by 4. In place of this I can write C pi over L. This is I. For minima, let us differentiate this with respect to L. So di by dl. This will be m by 12 2L, and this will be m by 4 pi L. This is a constant divided by pi L. And then you know one thing, but this L we have to differentiate, no? So I can write this as L to the power of minus 1. Okay, derivative of this. This is simple. Minus 1 divided by L square. Now this should be equal to 0. If this is equal to 0, you can lose few things. 2 and this can be lost 6. You can cancel something from here. Okay, this is like this. Bring it there. M and L will go to 0 here. Okay, so let us arrange it now. L by 6 is equal to L, that is 1 by 4 pi, 1 by 4 pi. This L square term is here, and you had L term here, 1 by L square term here. Alright, so write this as L square. Now bring back this L from here. So L can be replaced again, that can be replaced as, there was a constant involved, so that constant is here, C, sitting here nicely, C. Okay, so let us replace this L again. This will be C divided by pi r square. So I make this substitution here, C divided by pi r square. Okay, so I can lose this C, this C. I can do this pi with this pi. Okay, now L square by r square. L square by r square will be 6 over 4, that is 3 by 2. And then you know L by r should be equal to root 3 by 2, and that is our answer number 1. 1 is the answer for this particular question. Alright, let us move to the next problem. That is problem number 6. Again, a very simple problem. You have a rod here, right? The length of the rod is L, the mass of the rod is M. So that mass will act from here, mg. This is your L. So L by 2 and L by 2. Gravity will act from the center. You have this angle given to you as theta. So immediately you know that this will be equal to L by 2 cosine theta, and this will be equal to L by 2 sine of theta, right? Okay. Now what they want is angular acceleration. Torque is equal to I alpha. Torque of this will be mg into L by 2 of sine of theta. I about the edge is equal to 1 by 3 ml square alpha. So you can lose m with m, you can lose L with this, shift it here, this becomes 3 by 2 g, okay, g sine theta divided by L, capital L, okay fine, this will be equal to alpha. Let us look for the answer. Answer number 1 is correct for this, so that's it. 7th is a factual question. This type of question should be attempted first because you see there is nothing you have to think in this. आपको पता है अच्छे से, you know कि how the variation is taking place. Let it be the electrostatic field of a uniformly charged sphere or earth. From here to R it increases linearly, or if you come from the surface it decreases like this, and then it goes 1 over R square. Hardly a question, very simple, anybody can crack it any day. Okay, a copper ball of mass 100 gram. Mock test I gave you a similar type of problem, so it should not be a problem at all for you. That is, a copper ball of mass 100 gram is at temperature T. It is dropped in a copper calorimeter of mass 100 gram filled with 170 gram of water at room temperature. Subsequently, the temperature of the system is found to be 75. It is given that room temperature is 30, the specific heat of copper is 0.1 calorie per gram. Now, who is losing the heat? The copper ball. Who is gaining the heat? The calorimeter and the water. Alright? Heat lost is equal to heat gain, laws of mixture, principle of calorimetry. Alright, 100 gram of the ball. Specific heat is given to you, that is 0.1 calorie per gram degree Celsius. Okay, delta theta. The final temperature is settled to 75. So it has lost heat, T minus 75. This is gained by the calorimeter and water. So the calorimeter has a mass of 100. So 100 into 0.1 into delta theta, that term I'll write outside, plus the water. Water is 170 gram into 1. Now both of them have finally come to 75. Initially they were at 30. 75 minus 30. Now it is a matter of calculation. That is, if you take this out, you get 180 into 45 divided by 10, and that will be equal to T, because you see this will become 10, this comes down here, this and this gone. 18 into 45 plus 75. If you make the calculation, I think you get 885 degrees Celsius, so that should be the correct answer. See, rough calculations always can do the purpose. 45 and 2975, you see the nearest answer to that is 885, so you can pick it without any calculation. Okay, let us go for the next question. Again, a very simple question. 9th question. An external pressure P is applied on a cube, okay, whose bulk modulus is, let us say, B. In this problem they have given this to be K. What is the definition of bulk modulus? Bulk modulus K is increase in pressure, delta P, and modulus I am writing delta P and then V divided by delta V. So I can say delta V by V is equal to delta P, and this is your K. But we very well know if we have to bring it back to the original dimension, raise this and restore the volume, we know from expansion principle delta V by V is equal to gamma delta theta. But in this case they have given you alpha, so you can write this as 3 alpha delta theta. Make the replacement here, 3 alpha delta theta is equal to delta P divided by K. So your delta theta comes out to be P, that is change in pressure they have given as P, K, 3 alpha. And if you look for the answer is 1. Straightforward question without any problem. Now the 10th also is a factual problem. You know very well that Cp minus Cv is equal to R. Many times you write this as small p, Cv is equal to small r. that is, you divide this by molar mass. If you just think about it, what is the ratio of the molar masses of hydrogen and nitrogen? 14, that is 1:2, 1:28, so that will become your 14. Now, if you take some mass of the gas, then the number of molecules in hydrogen will be 14 times more than they will be in this particular gas. What is definition-wise Cp minus Cv? We know it is R, we know that. But what it is actually, if you look at the definition of Cp and Cv, how does it go? It goes as Cp is amount of heat that you have to supply at constant pressure to raise the temperature of 1 mole of gas by 1 degree Celsius or 1 Kelvin. Same for that, but at constant volume. So the difference between the two is basically that of work done. And in this case, in case of hydrogen, you will have to do 14 times more work because the number of molecules have increased. So to raise the same temperature, you will have to do more work. So clearly, A will be equal to 14 times of B. This again can be done very simply without, and if you say if both the gases are same, then of course Cp minus Cv is equal to R in that. Problem number 11. The temperature of an open room, volume given to you, temperature goes from 17 to 27, atmospheric pressure is 10 to the power 5, N1, Ni and Nf are the number of molecules, nothing to do in this. You very well know PV is equal to nRT. So when you're talking about N final, you will talk about PV divided by RT final, and Ni will be equal to PV divided by RT initial. Anybody's guess, you will just want the number change, so you can simply write PV by R 1 by T final minus 1 by T initial. Okay, so that will give you the change. Plug in the values, the answer comes out to be your fourth, that is 2.5 into 10 to the power. Do it yourself, it's just plugging in problem. 12th, all right. 12th, they have given you something. They have given you that T equal to 0, it is an equilibrium. It is at the position of equilibrium, the kinetic energy graph. It's a very simple question. You see, y is equal to a sine omega t, velocity is equal to a omega cos omega t. And you know 1 by 2 mv square will be equal to 1 by 2 m a square omega square cos square omega t. Cos square omega t, that means when the velocity is maximum at the mean position, the energy will be maximum. So option number 1 is overruled. 2 also goes because at t equal to 0 you have a minima. Now between C and D, the problem is at t by 2 it is coming out to be 0. You know the frequency of kinetic energy and potential energy is 2 times the frequency of oscillation. So they will complete their cycle in t by 2 time. So see the maximum minima, if you look at it here, it is maximum. At t by 4 it will become minimum. At t by 2 it will become maximum again, and then it will become minimum and maximum. This is the cos square graph that you conventionally get. So it's again a factual problem. You can solve it easily. 12th question. Look at the 13th question. Doppler, when we derived in the class, I used relativity, and now it pays, okay? So you know that you can write f prime is equal to f 1 plus v by c under root of that correction 1 minus v square by c square f, and this is f I already accounted here. You can cancel few things, and then you can write this as 1 plus v by c, and you can write this as 1 minus v by c under root f, and f prime, plug in the value v is c by 2, so you get root 3 by 2 divided by root 1 by 2, and f is 10, simple, 17 point whatever, so your answer will be 3. Okay, right. Remember whole derivation I did with concept of relativity, and we generalize the result as delta f by f is equal to v by c. That is when the velocity is very slow. Next question, 14th. Now in the 14th question, you know the torque. Torque is equal to what? Torque is equal to P cross E. You have a dipole in this problem. You have a dipole placed, let us say like this, at an angle theta. So if this is the dipole placed like this P can be very well written as P cos theta I cap plus P sin theta j cap, right? Okay, what is given to you? Field applied is E I cap. So P cross I. This is P cos theta I cap plus P sin theta j cap cross with E cross I, E dot I mean EI cross this will be, is given to you as something tau k cap. Now look at it. I cross I will always give you a 0 and sin theta, so P E sine of theta j cross I. What is j cross I? I cross j is k. J cross I is minus k. So minus k is equal to torque k. Okay. So now what you can do? You see, he has named this as T1. Okay, he has named this as T1. Here you see a k, whereas here you see a minus k. So I can just say that this term, if I write, I can write as minus T1. Now look at the second part of it. The second part of it says what? It says that is P cos theta I cap plus P sin theta j cap, and this time the field is root 3 E j cap. Okay, and he is telling that this is minus T1. This is minus T1. Minus T1. Now last time if you looked at it, you could have shifted this minus here. If you shifted this minus here, minus T1 will give you this result, right? So now if you cross this, I cross j will give you a k. So this is P E cosine of theta, P E cosine of theta, and that will be equal to this term, that is equal to P E sine theta. There is a root 3 term here, let me not forget that. Root 3 P E sine of theta. So tan theta is equal to root 3. So theta is equal to 60 degree. What is the concept? Torque is P cross E. Right. Next is an oral problem, NCERT problem, discussed many times. Simple. No pen required now. Look, you want what? You want a 2 microfarad capacitor, right? You want a 2 microfarad capacitor. What you have with you? You have 1 microfarad capacitor. Now the first requirement is you want that your system should withhold 1 kilovolt, that is 1000 volt. Whereas each capacitor in this case can withstand only 300 volt. So minimum how many you need? First requirement is to take care of the voltage. How many you need? 3 will not do, because 3 and 300 will make it 900. So you need minimum 4. So that 1200 will become the bearing capacity. You apply 1000. So now if I take 4 capacitors and put them in series, what will be the effective capacity? The effective capacity will become 1 by 4. But now the voltage problem is taken care of. Now I take n such combinations and make it equal to, I desire this to be 2, so n will be equal to 8. So 8 such rows like this of 4 capacitors each makes it 32 capacitors, and that 32 capacitor combo will be having a capability of handling what? Of handling 1000 volt, and at the same time it will be giving you 2 microfarad of capacity. Okay, next question. Look at the time constant. Again a very easy problem. देखिए यहाँ पिक्चर बना रहा हूँ इसका 16th. It is battery here, doesn't matter, plus minus. Okay, this is minus plus, how does it matter? कोई फर्क नहीं पड़ता उससे. R, and this is your R1, and here is a C, and then here you have what? Here you have a R2. Steady state condition, what would happen? In steady state, you know, this capacitor will open. If this opens, what will be the current that is flowing? The current flowing is equal to E divided by R plus R2. E divided by R plus R2. This is the total current that is flowing. Now, you want the drop across this. If you want the drop across this, multiply this by R2. So this is the voltage that is available here across this. No current is passing through this. Okay. So what will be the charge on this? You will say, okay, charge on this will be multiply this by C. So your answer will be CE into R2 divided by R1 plus R2. That option is option number 3. 17th, again a straightforward problem. Go in the loop, you get a 0. So if you get a 0, you know that the current in the resistors will be 0. If you want to make use of basic of nodal, start from this point. that bottommost point, name this as 0, call this as x. Now 2 volt will make it what? Here, if you make it 2, this will come to x plus 2, this will come to 2, x plus 4, 4 and x plus 6, and this is your 6. But these 2 points are equipotential. So this also will be equal to what? 6. No current in this. X plus 4 and 4, again no current in this. Then x by 2 plus 2 will be equal to 0, because in this case, if you just take the outer loop, you know that the current will be 0, minus plus minus plus minus plus plus minus plus minus plus minus. So there will be no current overall in the external loop. If there is no current there, the potential difference will be 0, same, so you will be, potential difference will be 0, so no current will flow. Alright, next question. Again, a formula based problem. This time paper, you're lucky, it's very easy. All the problems, most of them are just simple substitution of the formula. Just tell me the formula of time period. T is equal to 2 pi under root of moment of inertia divided by what? Divided by m into h. So this is your m into b. Look in the question, you are given magnetic moment, that is you are given the magnetic moment, you are given what? You are given the b, and you are given what? You are given the I. You know the value of pi, you know the value of 2, plug in the values, you get your answer, the answer will be 1. I am not doing the calculation, okay. 19th, what is the question? When a current 5 milliampere flows, Ig, that is maximum full scale deflection current is 5 milliampere, that is given to you. The Rg resistance is equal to what? That is equal to 15 ohm. So what is the maximum that this can handle? You will say Ig, Rg is the maximum it can handle, that is equal to 15 into 5, that is 75 into 10 to the power minus 3 volt. This is what you are capable of handling. Now what you want to make? You want to make a voltmeter of 10 volt. What is the formula? N is equal to what you want to become and what you are capable of. 75 into 10 to the power 3, that is 10 to the power 4 by 75. Now what to do? You put a multiplier in series. So multiplier m, formula is Rg into n minus 1. Solve it. 15 into n, that is 10,000 minus 75 divided by 75. Cancel this with this, you get what? 5. Cancel this, you get 75 is 9925 divided by 5. If you cancel this, you can get the value 1985. So this is 1.985 into 10 to the power of 3. That is the answer for your problem number 19. So 19, the answer is 1. Okay. Alright, let us continue. Problem number 20. So if you look at the problem number 20, what is given to you? There is a coil of resistance 100 ohm. R is given to you as 100 ohm. You are given a graph, and the graph is between current, that is 10 I, and here is your time t, and here it is 0.5. Can you write the equation for me? Sure you can. I is equal to 10 minus 10 by 0.5 into t. I is equal to dq over dt is equal to 10 minus 20 t. So dq will be equal to 10 t minus 20 t dt is t square by 2. T square by 2. And the limits, if you substitute, that is you are going from 0 to 0.5, that is 1 by 2. So your total charge that I will get Q will be equal to 10 into 1 by 2 minus 20 by 2 into 1 by 4. So let us clear this. This is 5. So this is 5 minus this is 8. This is 5 minus 1 point. Okay, 20 by 8. 20 by 8 is 20 by 8 is 10 by 4. 2.5. Okay, 2.5. So this is 2.5. Q is known to you. Many times I've told you charge is independent of the time. Delta Q, the charge that flows, is equal to change in flux divided by R. So straight away you multiply this 2.5 by the resistance. The resistance in this case is equal to 100. Okay, so you get your answer, that is equal to 250 Weber. So that is the answer number 3. Again, a factual, straight question. Next problem, we all know root V is, or rather lambda minimum Duane and Hunt law, lambda minimum is equal to 12400 divided by root V. Okay, not root V, but it is V in this case. Okay, now if we solve this, you can write this in this form. That is, take log of both the sides. You can write log lambda minimum is equal to log 12400 minus log of V. This is equation C minus mx kind of a equation. So you know that what are you going to get? So you're going to get something like this, negative slope. All right, 22nd problem. 22nd problem. 22nd. A diverging lens with magnitude of focal length 25 centimeter is placed at a distance of 15 centimeter from converging lens. So you have a diverging lens. Focal length is minus 25, and then you have a converging lens whose focal length f is given to you as 20 centimeter. The distance between the two is equal to 15 centimeter as given in the problem. All right. And then they want what? A beam of parallel light falls on the diverging lens. The final image will be formed where? Now here you have a diverging beam, this beam coming here, so you know this will appear to come from this particular point. All right. So now this focal length is given to you as 25. So this is 25. This is your 15. So for this lens, this object is placed at 40. 1 by V minus 1 by U is equal to 1 by F. 1 by V I have to calculate. Minus 1 by 40 is equal to 1 by 20. 1 by V is equal to 1 by 20 minus 1 by 40. This is 40, and then this is 2 minus 1. V is equal to plus 40. So these rays will come and converge again at 40. So the correct answer is the image will be real, and 1 is the correct answer for this problem. All right, next problem, Young's double slit experiment, NCERT problem. That is, you know, D is given to you 0.5 millimeter, that is 5 into 10 to the power minus 4. Capital D is given to you 1.5 meter, very nice. And then they are talking about two wavelengths. In such problems, you know, one wavelength is 650, another is 520, so 5 is to 4th. Fifth maxima of this will coincide with fourth maxima of this. So whenever you are doing the problem, I told you, if you are taking the higher wavelength, then take this, because you see, the two places, Y formula is Y is equal to N lambda D over D. N lambda D over D. This is the formula. Now, if this lambda, if Y is same for both, at same place you are getting the maxima. Y is same, if lambda is more, N has to be small. So if you are taking the higher one, take this smaller one, or taking 520, take 5. So okay, let us take 4. So I take 4, and then I take 650 into 1.5 into 10 to the power minus 9 divided by 5 into 10 to the power of minus 4. Alright, so you take this and 0 will cancel, 10 to the power minus 5 will come here, 5 and 15 you can lose, that is equal to 3. So 65 into 12 into 10 to the power minus 5, so 6.5 into 1.2 millimeter. Just try to see the answers. The answers are 1.56, 7.8, 9.75, 15.6. The nearest answer you can say 6.5 into 1.2, it will be 7.8. So the correct answer is 2. That's the answer to the problem. This was problem number 23. Let us move on to 24th. There is nothing in this problem. A particle A of mass m, initial velocity v, collides with a particle of mass m by 2 at rest. So what is given to you? m1 is equal to m and u1 is equal to v. m2 is equal to m by 2 and u2 is equal to 0. Okay, recall the formulas. v1 is equal to u1 m1 minus e m2 divided by m1 plus m2, and I am not writing the u2 term because that is 0. you know V2 is equal to U2 M2 minus EM1 plus next term will be U1, and then you will get M2 plus EM1 in case E is 1, so M2 plus M1 both are M, so this will become 2 times of M into, no, these are different, they are M by 2 and M, so let us not hurry up because it will spoil everything. M1 plus M2, M1 plus M2. Alright, U2 is 0, forget about this. Okay, and here U2 is 0. Now U1, V1 will be equal to U1, U1 was equal to V, M1 minus M2, so that will be M by 2 divided by what? Divided by total, that is 3M by 2. So you can lose 2 with 2, M with M, so this V1 becomes equal to V by 3. The mass is M, so the total momentum becomes mv by 3. Now in the second case, V2, I calculated here, V2 is equal to U1, U1 is equal to V, and then M2 plus M1 divided by M1 plus M2, U2 M2 minus EM1, U1 M2 M1 plus EM2, that is the same thing. So you get what? V2 will be equal to M1 plus M2 and M1 plus M2. Doing some mistake somewhere. M1 plus M2. What is the mistake we are doing? U1 M1 minus EM2 and U2 M1 plus EM2, M2 plus EM2, M2 plus EM2, M1 plus EM1, EM1, M plus EM1. So there will be 2 times of this, okay? So U1 will be V into, this will be 2 M1 and M1 will be 2M divided by 3M by 2. I can lose M with M, so this will be 4V by 3. Okay, but what will be the momentum? 4V by 3 into M by 2, right? So this cancels with this becomes 2mv by 3. Last time it was mv by 3. You know, de Broglie's wavelength, lambda de Broglie, that is equal to your h by p. You can see the ratios here clearly tell you in what ratio lambda a and lambda b will be. That is the ratio 2. The next problem is again a factual problem which I would not like to dwell into. You know, very simple problem. I do not know that why it was asked. Minus E, here it is minus 4 by 3E, and here it is your minus 2E. The change that takes place from here to here will be E. The change that takes place here will be equal to E by 3. So anybody factually can pick up the answer will be 1 by 3. Okay, 26th. All right, let us finish it off quickly. 26th question. 26th is a radioactive element A with half-life T decays into nucleus B at T equal to 0. At T equal to 0, there is no nucleus B. At some time T, the ratio of number of B to that of number of A is 0.3. Ratio of number of B to number of A at that time is equal to 0.3. You know, A is decaying into B. Alright, so if A is decaying into B, after T, how much has A decayed? So you will say, we know that NB will be equal to NA e to the power minus lambda T. This is what? This is the number that is actually present for what? That is present for A. This much of A is left over. This much of A is left over. That is Na prime. Na after time T is this much. And incidentally, this is the leftover quantity. So Na minus Na e to the power minus lambda T, this will be equal to Nb. So you will say fine, if you look at it, Na minus Na e to the power minus lambda T divided by, what is the number Na left now that you have calculated? Na e to the power minus lambda T, and this is equal to 0.3. we can lose Na, Na and Na, alright? Okay, so now if I shift it this side, then I can get 1 is equal to, this term will come here and this term will be here. So 0.3 plus 1 e to the power minus lambda. Lambda can be written as ln2 by t and t. Alright, so this is now 1 that is left this side and then remaining terms there. So let us arrange it and find the value of t. If we find the value of t from here, then this is 1 by 1.3 is e to the power minus ln 2, and this is t. So this will be ln of 1.3, ln of 1.3, 1 will be 0, and this side will be ln of 2, minus I am cancelling, and then this will be t and t. Okay, now if I write this in terms of log, you know that 2.3026 from both the sides can be cancelled. So this t now can be written as log 1.3 into t divided by log 2. That will be the t term associated with it. Next question. Common emitter amplifier, phase difference in output and input. Everybody in the world knows it is 180 degree. No discussion required. Next question. Again, doesn't need to be discussed at all. Why? Because it is a factual question. Amplitude modulation, what all you get? You get omega c plus omega m, omega c minus omega, and omega c. What you don't get? You don't get omega m. So the correct answer will be 1. Omega m will not be available. 29th question. Which of the following statements is false? This Wheatstone bridge is most sensitive when all the 4 resistors are of the same order. That's true. In balanced Wheatstone bridge, if the cell and the galvanometer are exchanged, the null point is disturbed. It is not disturbed, so this statement is false. A rheostat can be used as a potential divider. It can be used, and Kirchhoff's second law is based off energy conservation. That is again a fact. We know that is right. So correct option will be option number 2. That is, a balanced Wheatstone bridge will be disturbed, whereas it is not disturbed. The truth, it is not disturbed. Okay, last problem. Again, a simple problem for matters. T is equal to RHG by 2, and then you have a value here 10 to the power 3 Newton per meter. You know, in the experiment, what all you measure with the help of instruments? You will measure the radius of the capillary. What you will measure? You will measure the height to which the water rises. What you will measure? You will measure the T. That is, you are measuring T. G is something that is given to you using G equal to 9.80. So if that is not a measurement, you can straight away write here dt by t. dt by t will be equal to dr by r plus dh by h. Plug in the values, but here, as we have discussed many times, if they don't give you this dr term or dt term, then 1.45 into 10 to the power minus 2 is h, and diameter d is 1.25 into 10 to the power minus 2. So you know that here, if you look at this, the error part will be 0.01. 0.01 will be the error part. So 0.01 divided by the 1.25 term, and then here dh by h, this term is again 1.45 into 10 to the power minus 2, and this is 0.01 divided by this term, that is your 1.45 into 10 to the power minus 2. So that will come on the top, 10 to the power 2 and 10 to the power 2. Lose this, 1 divided by 1.25, 1 divided by 1.45. Sum it up, you get what? You get your answer, that is 1.5%. So 1.5% will be the answer of this particular problem. You want it in percentage, so you have to multiply by 100. That's the way to go about it. This is your paper.